what do air, milk, soil and brass have in common? Didn't get it? They are all mixtures. Air is a mixture of nitrogen, oxygen and many other gases. Milk is a mixture of water, fats, proteins like casein and carbohydrates like lactose and so on. Similarly, soil is a mixture of many things, and brass is a mixture, or more specifically, an alloy of copper and zinc. Most of the substances that we come across in our daily life are mixtures of two or more pure substances. We know that a mixture is not a chemical compound. In all of these examples, the different components in the mixture are not chemically combined. That is, they do not chemically react with each other to form compounds. There is one interesting characteristic of a mixture. Its properties depend on the proportion of the different components in it. To understand this better, let's make 2 cups of tea. Let's say we've added 1 sugar cube, half a cup of milk and some tea leaves in this cup, and 2 sugar cubes, 3/4 cup of milk and some tea leaves in this one. Since in the second cup we've added more milk, it'll be lighter in color. The addition of 1 extra sugar cube will also make it taste sweeter. Even though we've put the same components in both the cups of tea, there is a difference in their properties. So we see that the properties of a mixture depend on its composition. But more appropriately, we'd refer to tea as a solution instead of a mixture, right? Because tea is a liquid and liquid mixtures are called solutions. Is it so? Do solution and a mixture refer to the same thing? Partially, yes. In this video and a few upcoming ones, we'll learn about solutions, which are an important type of mixture. In front of you, there are 3 glasses of water. In one of them, we've added mud. In the other, we've added salt. And in the third, we've added sugar. Can you identify which glass has which mixture just by looking at them? Yes, you can easily identify the muddy water. But what about the other 2? We can't differentiate between the other 2 as both the mixtures look just like water. This is because in these 2 cases, we cannot see the dissolved salt or the sugar particles with our naked eyes. The salt and the sugar particles are evenly distributed in water. Whereas in the glass with the mud and water, we're easily able to see the mud particles suspended and settled in the glass. So, we can see that there are 2 types of mixtures. In the first mixture, its composition is not uniform, and its components are in different phases. That is, you're able to see the different components separately. So this type of a mixture, which has non-uniform composition and varying properties, is called a heterogeneous mixture. And in the second and the third mixtures, their composition is uniform throughout. And its components are in a single phase. That is, we cannot separately see the individual components. So this type of a mixture in which its composition and properties are uniform throughout is called a homogeneous mixture. For example, in a bowl full of mixed nuts, it's possible to identify the different nuts in the bowl, and the composition of the mixture is not uniform. So, it's a heterogeneous mixture. Can you tell me if a block of steel is a heterogeneous or a homogeneous mixture? Steel is a mixture of mainly iron and carbon along with some other elements. But these different components are not visible to our naked eyes. And its composition looks uniform throughout the mixture. So, it's a homogeneous mixture. Now, these types of homogeneous mixtures are called solutions. That is, a solution is a homogeneous mixture of 2 or more components. So, here the mixture of salt and water, the mixture of sugar and water, and steel are all solutions. But wait, as we saw before, we usually think that solutions are always in liquid state. But here we mentioned that steel is a solution. Yes, solutions need not always be in a liquid state. They can be in any of the 3 states of matter, that is gas, liquid or solid. For example, air, which is a mixture of oxygen, nitrogen and other gases. Another one is carbon dioxide in the soft drinks where the gas is dissolved in the liquid. So a solution can be in any of the three states of matter. Now here's a question for you. We know that the salt dissolves in water to form a solution. Does the same happen when we put salt in oil? No, right? Salt and oil don't mix. Why is it so? Think about it. In the upcoming lessons, we're going to understand this. We will see how a solution is formed, how their properties differ from their components, and so on. To stay updated and to keep learning such interesting things, do subscribe to our channel.